Okay, so I'm gonna start. Thank you very much, first of all, Kenny, for hosting this Pretoria meetup. We're very excited to be here from all the way from Europe. So that's very, very fun and exciting, as I said. And just briefly to introduce myself, I'm the community manager here at Camunda. I'm based in Malaga and I have many years of experience supporting developers in different roles. And I'm currently either driving or co-driving with Niall some of the community programs like the meetups, the champions, the educational license program. And I'm very much into outdoor activities as well as drawing and just spending time with my dog that you might at some point of the meeting maybe see her jump into my lap. And I'm always open for new connections. If you have any questions about the programs that I'm going to be talking about today, just connect with me in LinkedIn and I can give you all the details. But of course, I will be giving the links to Kennedy so he can just post them afterwards in the meeting notes. The Camunda universe is super big, and sometimes it's hard to navigate to the right resource, right? And as a community member, you have many ways to interact with us, to contribute, to participate. And I want to give this little tour around the universe around any little pigeon walking into Camunda. So the first program I want to talk about is the meetups, which is you are right now part of that program simply by being online, by joining one of the many chapters that we have around the world. Community members are running these events and they do an amazing job at pulling together people in specific regions, and they have a full agency to present the information and the talks that are relevant for the community. Another way to get in touch with us and with the rest of the community is the Camunda Forum. If you have any question whatsoever, this is the place where you want to go, where you'll find tons of people ready to help you, to answer your questions. And of course, if you are an experienced Camunda developer, there is space for you to answer questions as well. And that's something that we really like. People helping other people and just making it easy to navigate while you work with Camunda. Another way to level up your game is through Camunda Academy, which is our on-demand, our on-demand learning platform. You can access it online anywhere you want at any time of the day. And I've done several of them myself. They're very short, very easy to follow, and they also come with very practical exercises at the end. So this is a good way, as I said, to level up your game. Now, let's say that you are a very experienced Camunda developer, or you're just starting, but you find out things that you really would like to be different, or you have feedback that you would like to give to us. We have continuously UX research going on. So don't be shy. You can join a Zoom call, share your feedback, and just help us understand your needs better, and we can iterate and make the product really what you need. The Camunda Educational License is exactly what Kennedy was talking about at the beginning. This is a program that we have aimed to any educational institutions like universities or tech programs, and also targeted to students that are either doing research or writing their thesis. And the whole idea of this program is to give enterprise licenses to either teachers or students so they can teach or finish their research. There's an application form that I will give to Kennedy, but the idea is, as I said, just to enable and empower universities or students to keep learning, to innovate, to build new POCs, or simply level up their game. We also have a program called Camunda for Common Good. And the reason we have this is because we are committed to supporting NGOs and nonprofits that are making a positive impact in our world. So if you know any NGO that you think could benefit of this program, let them know. The idea is to give an enterprise account as well, have a dedicated CSM, help you build up, orchestrate and automate any processes within the NGO to give more time to do, good for the world rather than spending time maybe in admin tasks or things like that, right? We also have a champion program, and champions, you will see them whenever you join the forum or some of the meetups, are people that just love to help others. They are active contributors to the community in the shape of code, of answering forums, organizing events, talking about Camunda, helping others. And they, of course, are recognized. It's a way to also, as I said, recognize them and enable them to keep doing more. We support them in different ways. And at the moment, we are about to announce the 5th cohort. I think by end of next week, we will have the announcement, which is super cool because we had tons of applications from all over the world, awesome candidates, and we can't wait to have them on board. But if you already know someone that could be a champion, just let them know and they can apply throughout this year, and we'll have the next cohort joining us in October 2024. That seems very far away, but time flies. And last but not least, I also wanted to talk about the Camunda marketplace. This is, I think we will talk about it with Niall. I'm not sure about connectors, but this is part of Camunda ecosystem, and it's a way for you to also contribute with your own connector that might be relevant for your community. Niall, are you going to be talking about connectors, or did I just put you on the spot?
I mean, I can now. You've mentioned it. Sure, why not? Add like what, an extra 5 minutes to my talk? Sure, I'll knock together a slide while you're talking.
Good. So you'll be able to see how you can contribute to this marketplace as well. We have, I will let Niall do his magic while everyone else is talking. And finally, what I would like to tell you is that we not only have these ways for contributing, we also like to come together. And the next time the whole Camunda community will come together is in CamundaCon 2024. This is an event that will be hybrid. It will be happening in Berlin plus online, May 15 and 16. And we are currently we have opened the call for papers. So maybe you have an amazing use case that you want to share, or you've implemented something that is technically on the edge or groundbreaking or different. It doesn't matter if it's a business-oriented or more technical. We have space for both of those tracks, let's say, in CamundaCon. So submit your story, and we hope to see your name roll in. And we also have the help of developer advocates that can help you tune your message and even find the right tone, so you might have better chances of being accepted. It's not a warranty, but chances increase, of course. And with that, as I said, if you have any questions for me, just drop them on the chat and I'll be happy to answer them. And with that, I believe it's time for Thomas, but I will mute myself and let this continue.
Awesome. Yeah, thanks for inviting me, first of all, to the first ever meetup in this region. That's quite exciting, and I'm happy to share a little bit about the talk I brought, which is combining orchestration and choreography. So I'm going to share my screen right away. That's always the part where I'm getting nervous, because I hope that is going to work, and it does. That's awesome. Yeah, and I said talking about combining orchestration and choreography for team architecture. And just need to start the PowerPoint presentation, and now we can get going. Quickly introducing myself. My name is, no, my pointer doesn't work. That's already, okay, now it works. My name is Thomas. I'm a BPM consultant at Miragon, a consulting company in Augsburg, Germany. And fun fact, previously I worked as well in the developer relations team at Camunda, where there are two lovely co-workers from back then, Niall and Maria. Hi there. And for sure, I've already submitted my two submissions to CamundaCon Europe, which is great. So I'm looking pretty much forward to it, and I can encourage everyone to submit something because the event in Berlin is truly nice. At least it has been last year. And this talk actually has been initially presented at the Community Summit back in 2023 in May. And I've changed a couple of things, updated a couple of things. So it's not the original talk, but a modified version of it. Cool. Having said so, there is a very short slide about Miragon, so you know what the company is doing. We've been founded in 2020. We do have a couple of projects at our hand are in total, have 12 team members, which all work with Camunda or process automation tools, as well as DevOps stuff. In general, we offer trainings for BPM and DMM architecture, consulting, of course, typical professional services, as well as some workshops, for instance, Camunda proof of concepts or quick checks. So that's what we are doing, and that's already enough in a bit, because now we are taking a look on today's topic, what we are going to discuss in this talk. So we'll start off by chatting a little bit about challenges in distributed systems, how we, for instance, can handle exceptions, retries, and what if inconsistencies happen. Once having done so, we are going to try and apply orchestration to the problem and also chat a little bit about what orchestration actually means, what the workflow engine is, and how we can model some processes in a good fashion. Once this is accomplished, we'll then go on and talk about writing clean code and creating a clean architecture for our process application. We'll chat a little bit and take a look on a live demo where we'll show a hexagonal architecture and also chat a little bit about how to implement engine-independent code, which works with Camunda 7 as well as Camunda 8. And once this is done, there's one last topic, which is adding choreography to the game. And I called it scaling up, not in a sense of adding more power or compute power to the process engine, but rather spanning our process across multiple domains, adding multiple development teams to it, and how we can actually achieve a good work with multiple teams. So that's the point where we talked about domain-driven design, choreography, and how to throw domain events in these kind of applications. Cool. Usually I would also highlight the Camunda connectors in this talk, but since this is the first ever meetup in Africa, I decided to start from the ground up and explain also a little bit why a process engine can be quite important in distributed architectures. And that's what we are going to start off with. And we are talking about pizza, which is pretty bad because I haven't eaten dinner yet. I'm still running on lunch, so I'm going to get quite hungry through the talk. Let's see how this will be going. But yeah, in our fictional use case, we are taking a look at a restaurant. And in this restaurant, we want to apply some digital transformation, digitalization, and hence we are going to replace our waiters with a digital waiter called James. And James is kind of operating or being operated on a tablet, and customers of ours can then click on the tablet to order stuff, to pay. All these kind of things are possible with James. And in the first draft, they have decided to basically use synchronous blocking communication. So James directly calls the API of our kitchen service to communicate an order to the cook, also directly communicates with the payment API, and all of this resulted into quite some problems. And that's what I wanted to talk about when chatting with or talking about distributed systems, because introducing synchronous blocking communication, which is frankly speaking being often used, has quite a bit of drawbacks. So now imagine the kitchen chef or the cook is going on a break, and the waiter is going to send over the request for a pizza. But since the cook isn't there, there is a timeout showing and James crashes. So we don't want this to happen. And using synchronous blocking communication, the probability for this to actually happen is not that small. And also another big deal is that you have implicit event chains. You can see how these services are actually interacting with each other. And out of the box, there is no retry and exception handling mechanisms. And you typically would need to extensively add some program code to make this possible. And that's where an orchestration engine can chime in very quickly. And especially for these kind of long-running tasks, as highlighted down below here. Do I have a laser pointer somewhere? Yes, I have. Down here, where we order a pizza, which can take quite some time to come back. We deal with those kind of long-running tasks, which can be a problem for us, especially for these distributed systems where we want also things to run asynchronously. Another thing which would be the worst case scenario is something like this. And I know this very stylish use case was initially developed by Niall for the Camunda 7 talk. And I just took it and made it compatible with Camunda 8. And the problem is obviously that if the kitchen, for instance, is not available, we result into some kind of exceptions which are being propagated to the user, which might result into a very bad user experience. So that's kind of the problem when using synchronous blocking communication in our distributed architectures. And for that purposes, orchestrators and workflow engines are ideally suited. They provide a scheduler which can then actually retry, wait, escalate, compensate. We have a durable state, which is basically a database where we can see what has happened and what needs to happen next. We have typically those wait stages, and also very powerful instruments are these visible workflow definitions. Besides of Camunda, there are, of course, some other BPM suites and engines like JBPM, Flowable, Visagio, and Pika. For sure, you have heard of some of them since they can get quite big. But of course, for today's event, we'll very much focus on Camunda because that's as well the developer-friendly one, which is quite important for me at least. Having said so, what actually is orchestration? What are workflow engines actually doing? And later on, we'll also learn how this differs from choreography. So orchestration means basically we are command-driven communication. And a command-driven communication, we actually want something to happen as a sender. We do have an intent in our message, and maybe the recipient does not necessarily know who issued the command, but the intent is basically there. So for instance, a command would be, I order a pizza margherita. There's a clear intent in it because I want to get the pizza margherita. I'm not just saying, for instance, I'm hungry, which would be in contrast an event. So that's kind of orchestration. And I also, for our pizza situation here and restaurant situation, I also brought another example. And in this case, the command would be up here, which means I baked this pizza for Andrea. Please package it immediately and deliver while it's hot. So this message has kind of an intent. It's the command, whilst the pizza salmon is ready. It's just an event because I don't know what I should do with it. It doesn't have the intent. So that's kind of the differentiation between event and command, and orchestration purely uses command-driven communication. And in a workflow engine, we basically have all these things kind of working together. Now we also see kind of the visible workflow diagrams up here where, for instance, a payment was required. We charge the credit card. We call some piece of code to integrate to REST service. We have this kind of durable state. In Camunda 7, this has been a typical relational database. Nowadays, things have changed a little. And I can basically call this process whenever I want. So that's kind of orchestration or workflow, the Camunda workflow engine, or in general any workflow engine, summarized in a couple of slides. But today, as said, we are going to take a look at Camunda Platform 8, the workflow engine of our choice today. On the right side, you can see the architecture of the platform. So basically, we have Zeebe brokers, which can be scaled, so we can have one or many, and they export their data into Elasticsearch, which is then being consumed by Optimize, a tool for analytics, TaskList, a tool for human task management, and Operate, which is used by the process operator to take a look into the process instances, into their lifecycle, and is able also to troubleshoot some incidents there. On the other side, we do have the web modeler and form builder, which is kind of a modeling tool, cloud-based. There's also a desktop application for modeling BPM and DMN diagrams. And of course, we do have our kind of process application, which is being the job workers, some kind of worker, some kind of client, which then connects to Camunda 8 and works or executes custom logic, which is not covered in user tasks, for instance. So the engine itself is open source, which is quite great. The rest of the products apparently not. And the tooling is available on SaaS as well as on-premise. And for today's demos, we are going to operate it through Docker. So I do have my Docker Compose file booted up, and we are relying on that part for today at least. Also, some big benefits are the use of the standardized BPMN notation, business process modeling notation. So that's standard for capturing processes. It's defined by the object management group, similar to the decision modeling notation, which is the DMN standard. And simply, it's used to capture these workflows and decisions. And of course, the Camunda community is quite vibrant and developer-friendly, as you might know by now, because I think we are 34 people in this meeting, which is quite good for a Thursday evening, at least from my experience. Cool. So now let's take a look on the BPMN diagram we'll discuss today. So on the right side, you can see the model. As said, it's standardized. The great thing about BPMN is that it improves understanding and facilitates effective communication amongst multiple stakeholders, not only IT people, but also the business side of things. And this model can be quite easily understood if you got a rough understanding about this graphical notation. Another thing is that this also enables analysis. So with Camunda Optimize, I could potentially analyze my data from process execution and can see clearly where some bottlenecks have happened. But to today's use case. So this is basically our restaurant showcase, and we can see we can see our digital waiter or the process from our digital waiter up here. So as soon as we received an order through front end, we basically decide where to eat, whether it's takeaway or dine in. And basically, in case we dine in, we need to prepare a meal, we need to serve the meal, and then we need to receive a payment, of course, before we then issue the check and hand it over. Awesome. If that's done, the process ends, which is great, but it can also happen that the customer wants to take it away, the food away. So we need to prepare it and issue the check in parallel, and then basically at a certain point in time, it's ready to be taken away, and then the process ends as well. Down here, we also have an event-based subprocess for handling delays. So in case the processing takes longer as a minute, which should not happen. Maybe that's not very realistic, but we'll just take it. If it takes longer as a minute, we basically reassure the guest. We'll show a display on we'll display a message on the tablet saying basically, hey, we are on it, your order is still safe, and we try to be as fast as we can. And then hopefully the guest is calmed down, because we haven't simply established any other mechanisms for handling these delays yet. So that's the process which is going to happen. And we do have our digital waiter service right here, which is responsible for the whole domain. So every service task is basically being handled through our digital waiter service. It's kind of a domain service because we do focus on the domain of the restaurant right here. And whenever needed, the domain service of the digital waiter service then calls either the kitchen or the payment. And that's also something which contradicts with the idea of connectors, because in case we would have used connectors, we would have called them directly. But for sure, this also has some drawbacks, and I decided for kind of the cleaner approach, which is basically to wrap our process around the domain service, which is handling all the domain-specific work like preparing a meal, issuing the check, even though some external systems are called afterwards. But maybe, or in this case, not only maybe, there's some domain logic in there as well. Awesome. Having said so, let's take a look on writing clean integrations. So just to highlight the purpose of why we want to, or as a developer, why we want to write clean code or use clean architecture. And in case we do so, we divide up the system into parts, which each of them having a specific responsibility and clear dependencies. So that's kind of the definition of clean architecture. And the benefits are obvious because it leads to some increased maintainability, testability, scalability, flexibility, and collaboration. So it has huge advantages if I do write only spaghetti code and wire up my application as I want to. And if everybody do so, we end up with a huge mess. And clean architecture is a way to avoid this. Awesome. But what does this mean, especially for writing some domain services or integrations with Camunda? And that's what I'm going to show you in this slide, because we do have some hexagonal style integrations. That means we do have kind of such a nice hexagon. In the middle, there is the domain, and we are kind of thinking from the domain to the outer layer. So the domain is pure in itself, and all dependencies point towards the center, basically. So the domain isn't reliant on any use case or any adapter. And this means the domain logic is also completely separated and completely independent from our databases, from Camunda. And this makes it possible to simply use some in and out ports and adapters, which then contain the domain-specific or the technology-specific implementations, for instance, for Camunda 7.8. The benefit is obvious. If I want to change or make my component compatible with Camunda 8, I replace the driving or the outgoing adapter with Camunda 8. And if I want to use Camunda 7, I just put Camunda 7 in there. So the use cases themselves of my service and the domain logic stays completely independent from our technical surroundings, which is great in terms of reusability and allows an organization to stay kind of technological independent and does not, the risk of getting into vendor lock-in is a little bit limited, which is usually a good thing. Awesome. So that's kind of the architecture we are going to use in today's session. And what this means for our waiter is played in the next slide. So now we've got a more or clearer architecture diagram. We do have some domain entities such as order and food for our waiter. We do have use cases such as place order, prepare meal, serve meal, pay meal, issue check, so on and so forth. So all these is encapsulated in use cases. And then we do have these kind of adapters, which I've mentioned earlier. One for Camunda 8, which is driving our waiter component. And we also have some out adapters, for instance, to our payment provider, which could potentially be PayPal or Stripe, for instance, for the kitchen. And Camunda is also being driven in a certain sense. It's not displayed here, but every time, for instance, we trigger a process in Camunda, it would also be an outgoing connector. So that's the architecture diagram for the session. And now we are also ready to take a look into code, which will be the interesting part. So let me quickly quit PowerPoint. And now I've opened up our demo application already. So as said, everything is running locally. We have operate opened up, task list opened up. But first of all, we will quickly run through the process so you can see what's happened. So I'm just ordering for myself a pizza prosciutto. and choosing to dine in. I basically submit the order. I can see that's something happening in the background. I can see an operate process instance has been started and the meal is being prepared. So let's go into here, and in operate, I can basically see everything happening in the process. The pizza is ready, it's being served, and now they're waiting for me to say, hey, I'm ready to pay. And yeah, I can actually see that this has happened here. So they tell me, hey, here's your pizza prosciutto, and now I basically eat. And when I'm finished, I can press pay now, and we hopefully see the process continuing. Let me quickly refresh. And yeah, we do see now the check is being issued, and then I will potentially hand over the check since this is all automated. Yeah, and the process has finished. Definitively, a nice thing is that I can see all my variables down here, and the process engine also has some other peaks. For instance, I could potentially modify process instances in case I want to replay a certain behavior in my process. I could move the process instance to another point in the process, potentially, if I wanted to do so. And these are quite some powerful features of the process engine itself. Cool. But that's enough about operate. Now let's dive a little bit deeper into the code I wrote for that purposes. So going to throw IntelliJ into here. And yeah, where should we start? So let's start by the project structure. So basically we do have our module here called Restaurant Showcase. In there are multiple programs. There's the kitchen service, and the kitchen controller, for instance, features the REST API. So we can see here a clear request mapping. So when I call our kitchen servers, kitchen application, which is running on this port down here, we can basically place an order. So we have a RESTful service for kitchen as well as payment. And we do have our waiter Miranum application here. And now I want to tell you also a little bit about Miranum. And because that's a framework which is not being maintained by Camunda, we at Miragon wrote this. It's open source and publicly available. And this framework is basically an abstraction of Camunda's APIs. And as you can see here, we do have a worker API where we can fetch and log tasks, complete them. We have a process API where we can start processes, a message API for message correlation, and then we do have the Camunda 8 specific implementations. And as I said previously, since we are using the hexagonal architecture, I can easily replace these connectors without breaking any of my code. So if I now want to use Camunda 7, I can just enter Camunda 7 in here, download the dependency, which is already pre-installed or cached by Maven. And then I could operate this whole process with Camunda 7 and just need to keep in mind that I need to change the process diagram because that's not platform independent or workflow engine independent.
Hey, Thomas,
kind of,
sorry to interrupt. Can you zoom in on the code a little bit? Chat are asking just if you can.
Let me see. I always forget the. Wait, I know how. Yes. Hopefully this is better. Now I just need to do so for every file I open. So it can happen that you need to remind me again. Sorry for that. But yeah, as said, I can quickly change C7 to C8 or to any other workflow engine if I have an adapter for that. And my code is still independent from that. Cool. Having said so, let's dig deeper into the package structure. Apparently, I can make the package structure bigger, and for a hexagonal architecture, that's quite important because the structure is quite special, and it differs between the adapter, the application, and the domain. The domain features domain objects. So, for instance, in here, now I need to make it bigger again. In here, we do have for instance, the class of the order. So it's basically a Pojo with some constructors in it and nothing more. The same applies to food. Here you can see the hard-coded options of hamburger, cheeseburger, and so on and so forth. Should maybe be handled differently, but for the time being and for demo purposes, that's the easiest way to handle it. And we also have something like dining option, which can be defined. And these are my domain objects, which are relevant for this worker or for this domain service. In the application layer, we do have various services. For instance, the pay meal service. And this basically then implements the pay meal use case. The pay meal use case. So everything is nicely abstracted through interfaces, which ensure that I don't have dependencies pointing outwards, basically. Yeah, the ports are basically defined here. I won't open them now. They are simply some interfaces and some commands. And we do have our in and out adapters, where we, for instance, have some REST controller in there, which handles the request from our front end, which we've previously seen. And for instance, also all the workers specified from Camunda. And there you can see, hey, add worker, issue check, and everything is defined in the process accordingly. And of course, there are also some out adapters. For instance, for message correlation, we use these kind of out adapters, or for starting a process. This is also being used. So that's kind of the overall architecture we use in this demo, and for displaying how a hexagonal architecture could benefit during development. Having said so, I think that's it for now. There's another little demo for talking about how we actually deal with choreography. So let me continue from current slide. Yeah, that's the correct one. And continue with scaling up. So the last chapter already. And as said, with a clever mix of choreography and orchestration, we can actually reach quite some good level of decoupling, which is always good. We strive for such a thing in development or in engineering. So starting similar to previously, we'll now quickly chat about what is actually choreography. So in contrast to command-driven orchestration, in orchestration, we now use event-driven communication. And an event, as already quickly pointed out previously, is something like, hey, I'm hungry. So throwing this out into the crowd, some of you might do nothing. Some of you might start baking me a pizza or something. I don't know. But I cannot control what's going to happen with this event and who is going to pick up the event. It's rather a fact which has happened in the past. It might change quite quickly. So if I say, hey, I'm hungry, somebody might bring me some food, another person might be cooking something, and then I'm already full as soon as the other person gets ready with a dish. So yeah, that's choreography in a nutshell. So now we also want to apply domain-driven design, because we want to use this event-driven communication and choreography in a clever fashion. And for that purpose, in my opinion, domain-driven design is quite suited. And this is an approach for software development that centers on programming a domain model that simply has a rich understanding of processes and rules of a domain. So that was the definition from Martin Fowler, who is quite an important chap in the development world, I would say. Oh, no. Damn it! How now I have a pen and no laser pointer, but that shouldn't be a problem. So Martin Fowler said this, and we are going to make use of it. And as this definition already says, the domain-driven design also has this understanding of processes, and we are using processes. So why not combining those two approaches, which can be quite similar, to one? And that's what I've done when I have evolved the architecture. So as you can see here, we do have our waiter service, which does exactly the same as we've previously seen. And we have introduced a new satisfaction service. Since the restaurant has moved away from physical waiters, human beings, to the digital waiter, they have now a ton of staff. They didn't want to let go of the staff, so they decided, hey, let's open up a quality assurance department. And the quality insurance department is now responsible for the satisfaction or customer satisfaction process, which is being started at a certain point in time after the customer has been served and has eaten already something in the restaurant. So this is a whole nother domain in contrast to the waiter. as we see above. And now we want to kind of handle the communication between them. And my approach was to basically publish domain events from our restaurant process to a message queue, or basically to Kafka in this case. And there we are talking about domain events. And that's now choreography, which we are adding to the game. So let's talk a little bit about the bounded context, because that's the technique we have used while modifying our architecture to something like this. Contexts do exist in domain, and we do have our restaurant context on the right side. We can see we have the domain objects of food and order. We've also seen them in code previously, and now we do have the quality assurance context, which is responsible for kind of this new service, domain service, which was introduced for the new process, which was introduced and which is owned by the new service. And this also has some shared concepts, such as the order, but also some completely different, such as customer and evaluation. And there might be many, many more objects which are relevant to our quality assurance context. And this is basically a pattern for allowing us to creating dependencies between those multiple contexts. And as we can see, they somehow need to interact with each other. What we are going to do. And I will show you before we actually talk a little bit about handling events, or a best practice about naming event. So now exiting. Oh no, I want to discuss this. So going back into the live demo, and I think there have been some slides shuffled up, which is quite weird. This shouldn't happen. I think that is the right way now. Cool. But going back into the live demo, back into code, we now, and I skipped this previously, we now throw domain events. So we've specified those domain events in our domain itself. For instance, there is the, where is it? Meal, no. Oh, we can take anyone. Issue check one. So it's defined something like this, and that's it already. So it's not much, which is done there. We just defined the object of an event, of a domain event in there. And this one is now being thrown in the issue check service. Exactly. So we have an application event publisher right here, which now publishes the check issued event with our order object. And now, through our whole hexagonal architecture, it's then being published in our Kafka adapter, more or less. So this is an out adapter, and we are going to publish a domain, for instance, on meal paid, or any other domain event. So we are throwing quite some domain events into Kafka, not only the one which is responsible for saying something when the meal has been paid. And what this is doing now is it triggers our satisfaction Mirano process, which is implemented right here in this domain service. And we do have a Kafka in connector, a consumer, and this consumer basically listens on the restaurant topics, and then is being executed on order, or on the order handled event. Exactly. So that's then basically going to start a process in Camunda 8 via a message. Great. And we are also including all the details which have been inside of the event. So let's see whether this has actually happened. You remember we walked through this whole process, and now we should be able to see, oh yeah, there has a new process being created. We do have the customer satisfaction survey up here, and we can basically see that we now should maybe contact or call the customer Thomas, who ordered the pizza prosciutto, and the order ID was something like this. And in task list, I can also now see this activity, assign it to me, and then work on it. And maybe a problem would be that I don't have a telephone number or a mobile number, which would cause the service rep, the QA rep, not to call Thomas. That is a a little bit of a problem here. But maybe we need to evolve the process. And having said so, the second little demonstration is done. So we can skip to the next couple of slides and end this session, because I also wanted to share with you when to throw or how to throw the right domain events. There are some best practices I've tried to summarize. And now I'm going to choose the laser pointer. So yeah, definitively it's very important to use very clean names. Do not use events, because then it gets untidy, and event-driven architectures can have the problem of being very, very hard to understand, because you have a lot of invisible event chains, which are hard to track. So that's why it's so important to use clean names. Only throw events when data has been manipulated, created. So that means created, updated, deleted. You don't want to throw an event if you simply just read data and never expect something to happen in return. So don't throw an event or don't publish an event and wait for an answer without handling any exceptions from a process point of view. Then rather use something like a service task or an external task, and orchestration. And yeah, try to use it only for communication outside of the bounded context. So if you are talking to completely external systems, which are not part of the context of the domain context you're currently operated in. And with having said so, here are some key takeaways. So our patients are clearly that the services, domain services, should be designed in a technology neutral fashion, that we want to use domain events for communicating outside the box, for making sure that the system is as loosely coupled as possible. And with the hexagonal architecture, especially in very difficult domains, you gain quite an advantage in maintainability. So imagining an insurance or something like this, who has a ton of rules, business rules to be evaluated, to be checked, and a rich domain model there in hexagonal architecture surely is very beneficial. And yeah, for ideal decoupling, you should use both choreography as well as orchestration. And with having said so, I'm done with my talk. Thanks for tuning in and listening. There is a GitHub repository. This URL code should still work, hopefully. And yeah, that's it. Thank you. If you have any questions, feel free to post it in the chat. And I think the next one speaking would be Niall.
Yes, it is indeed. But I will give people maybe a short break, just because to take in everything that Thomas just spoke about. In order to ensure you'll come back, I can guarantee that my talk involves dinosaurs and a prediction on the rugby on Saturday. So you're going to want to stick around. So yeah, we'll say that people can go and get a drink. I've already gotten mine, so we'll see you back here, let's say, in maybe 5 or 6 minutes, and then we'll kick things off.
Thank you so much, Niall. Okay.
That's a great idea. And Niall, it's good that you restart your camera, because your video, at least on my end, lagged very hard.
That's just my hair.
Oh.
Alrighty, I have returned. I will get started in a minute or so. I'm glad you're eating now, Thomas, after all that pizza talk.
It's apparently not food, it's only beer, but...
Oh, is it? I hope it's Bavarian at the very least. You haven't...
Oh, for sure.
Of course
It's,
it is.
wait, can you see it? It's
Oh,
Tegernsee.
wow. A very traditional Bavarian Helles. It even has a
Yeah.
Bavarian flag on it.
It's true, but it's just a small bottle, so that's something very special, kind of, because it doesn't exist here. And its due date was yesterday, so let's see. Hopefully, nothing happens to me.
So this could be your last talk ever. Everyone in the chat, this could have been the last time we see Thomas perform dead from poison beer, which is the way we always thought you would go, Thomas. So
it's worth it, 100% worth it.
Yeah, even a poison Bavarian beer is better than a regular Berlin beer, right?
Oh yeah, no, wouldn't drink that. Just kidding. Cool.
Ever had a Peruvian beer? But Juan, how much would it cost to post one? I, of course, am drinking. I'm actually drinking in a German beer glass, but it is a Belgian beer called Quack.
Ooh.
Spelled Kwak, I think.
Mm-hmm.
It's a good one. And yeah, I think I've talked enough about what's going on. I hope everyone else has a nice drink and that sort of thing. I'm going to kick things off with a wee chat now. It's been about 5 minutes. Okay, and during this presentation there will be dinosaurs, so I will be warning you all to duck. So prepare yourself for that. Let's start by finding the share button. Let's go with select my screen 1 or screen 2. These are the questions. Okay, let's try. Did that work? Oh, look at that. Amazing. Okay, cool. So let's spin over here for a while. Now I can't see you anymore, but can somebody give me some sort of vocalization if my slide is visible?
Looking good.
Marvelous. Thank you very much. So first things first, Thomas gave you a very, very good chat there about using Camunda in modern architectures. I'm going to take a slightly different angle here, and I'm going to talk about how we got to where Camunda is, the evolution into what Camunda 8 is, and how that happened. Those who may know Camunda, there's two main versions. There's Camunda A7 that lasted for a very long time. And then about 2 years ago, we, for the very first time, increased the major version and released Camunda 8, which has loads of fundamental differences, but it matches very closely with the growth of how modern architectures function. So this talk is going to be really interesting if you're interested in how modern architectures have gotten the way they are and the kinds of things that make those work. And for those who don't know, I am Niall. When I go to weddings or court appearances or whatever, this is generally how I look. I wear a fancy tie. I feel very happy to be here because, like Maria, who introduced, I have family who live in Spain. Like Thomas, I currently live in Germany. And of course, like you lovely people, I actually grew up in Pretoria. I lived in Centurion for a long time. And traveled around there quite a lot. I miss it loads, especially this time of the year when it's starting to get cold in the northern hemisphere and it remains very lovely in the southern hemisphere. So count yourselves lucky. I'm a developer advocate with Camunda. I talk a lot about it. I've been with Camunda for many, many years. And if you have any technical questions or otherwise, I can probably answer them. So let's start with history and let's go back to give you some history about how we ended up with modern architectures we're currently dealing with. As I mentioned, first of all, there was nothing. Okay, I'm going back quite far now, so don't be too worried. But in the beginning, there was no time, no nothing. Skip ahead a bit, and then we had those dinosaurs I mentioned earlier. Now, unfortunately, this was a very rough time for a lot of software developers, as dinosaurs and software developers don't often get on that well. And in fact, to our knowledge, almost no software was written during this period of time, probably because of the dinosaurs. And the tiny hands don't help with typing on keyboards. Now, luckily, skip ahead a little bit, the dinosaur problem was basically solved. It fixed itself. Don't worry about it. There's no dinosaurs anymore. So we're all good. Oh, and duck. There's an asteroid. Okay. So what happened next? Well, something far more sort of precarious for developers was created. We're skipping ahead now to I would say the 90s, late 90s, early 2000s. And the type of software being developed was this. This is a monolith. And now, Thomas alluded earlier that most architectures nowadays use distributed systems and this whole clean code architectures that exist that talk about this. But why is it that we moved away from these lovely monolithic systems, and what did they work like? So let's imagine you're a bird. I'll give you a few moments to imagine that. The kind of bird is up to you. I'm going to imagine I'm a hawk. And let's imagine you want some information. Well, in a monolithic system, there is one big blob, and inside here are all the functions you need in order to get the information you're looking for. They're all beside each other. They're all happily, very, very tightly coupled. If you as a bird ask for something to the monolith goes ahead, doesn't need to talk to anybody else, and spits out a bunch of stuff. In the past, this would be a very big Java application, maybe deployed to Wildfly or whatever Wildfly was called before JBoss, right? What was Wildfly called before Wildfly? It was something. Anyway, or Tomcat or something. And that's kind of where it would sit. This big server with a big chunk of code, you ask it and it comes back, and it never needs to go over network. That's the key thing. So that means that you have this big blob of thing, and therefore you get to chat about it. Next up, what was the problems? Why did we change things? Well, the monolith had some problems, and this coincided with the growth of software in general as a thing that everybody started to use. And of course, the internet did not help this. The first thing is scaling. If you have a single server, you have with one big blob of code on it, you have a very limited amount of resources. There's only a certain number of calls you can make to that service, a certain number of responses, a certain number of times it can commit to the database. It's very, very limited. And so scaling those big monoliths became very hard because all you could do is make the server chunkier and bigger, but you were always going to run out of resources eventually. It was limited by scale. The second problem was service update equals system update, by which I mean if you had to update even the smallest part of your monolith, you probably had to take down the whole service to update any small part. So that meant that changes actually took a long time because you don't want to have to update the whole service just because one thing needs a change. So what would happen in the development services would be loads of people would group all their changes for a monolith together, they'd stick it all in and then release it all at once and hope it would all work. That was a problem because then you couldn't really do things in a very agile way. You couldn't have a single service that, let's say, got updated quite frequently while another service didn't really need to update very frequently. Also, error handling was hard. The reason was it was hard in a specific way. Error handling with monoliths happened internally and generally through an error within the service. And that was hard because to understand what went wrong, you generally had a big failure of the entire monolith, which was a bit of an issue. You would rather have an ability for something to fail, but be able to be caught and dealt with later. And that was quite hard to achieve in a monolith. So instead, some very clever person decided to take out all the individual services and stick them in different parts of the internet. That created, of course, the ability then to say, ask one individual service for something. Let's imagine that let's go with ordering pizza because Thomas started there. So let's say we order pizza, but of course the pizza there's no cheese available. So we have to ask the cheese service. The cheese service doesn't have the cheese grated. So it has to ask the grating service. So while this thing needs cheese, it says, can you give me some cheese? And it says, yep. Can you grate the cheese? It comes here. And then of course, the cheese comes back. So grated cheese goes there and the cheese comes here and we get our lovely cheese pizza. Salmon pizza? Really, Thomas? Salmon on pizza? Anyway, I'm sure it's fine. I'm sure some people like that. I'm not sure who they are. Hey, anyone in the chat who likes salmon pizza? Post now. I doubt that anyone will. Anyway, so we get our pizza and then there was some problems with this. The first thing was, well, this did solve a lot of problems. I should probably mention before complaining about it. The first thing is that these are now more independent. So now you can have different, completely different languages. They have completely different owners of these things. And it was much easier to build them independently. They didn't require one big change to have to go through them. So that was quite good. It solved a lot of the monolithic problems. It also fixed some scaling issues to a certain degree. If every single of those microservices had their own resource bucket, so their own number of requests they could handle and their own number of commits to the database, which then spread out. That's quite good. There were problems. You may know this. This should all be history to you that I'm sure you're aware of, but it's nice to recap history every now and then. And first is, of course, latency creep. Latency creep was the biggest problem with microservice architectures and systems, and that is the longer you have a chain of calls, because those calls are synchronous, the longer the amount of time a thread has to stay open, and eventually a thread has a certain amount of time it's going to stay open before it eventually rolls back. You had a certain number of calls you could really make in a row before eventually it would fail just by sheer length of the call, which was a bit of an issue. The second issue, of course, was service failure equals system failure. One of the issues here is, if we go back here, if let's say the grating service changes, you just do not get a cheese pizza. Not going to happen, because what will happen is it'll say, can I get a cheese pizza? This thing will say, here's the cheese. This will say, can you grate it? And then this will just say, no, the grater's broken, can't do it. And it'll roll back and just say, no, nothing for you. This is a bit of a problem, which means if anything fails along the way, the entire call fails, which is not great. It's also a bit of a black box. This wasn't such a big issue in the very beginning of microservices because there weren't many of them, so you can document them. But after a while, when these became default, you ended up having so many services calling so many other services, it became very hard to know what is happening across the network, which is, pretty bad. Let's imagine I'm making a call from this service. I have no idea that this service is also being called somewhere down the line, because, like Thomas mentioned, abandoned context, it's only aware of its own context. Okay, so what happened? Well, what started to happen was people started to introduce another part of an architecture, like Kafka, like messages. Now, why is this different? In the previous example, our little bird, a little hawk that we can imagine, would have talked to this service, which then would talk to this service. Now, this requires the little bird both to know about this service, and also it requires this one to know about this one, right? So we changed things by adding a message service. So instead of having a call to say, go do this, we put a message in a queue in Kafka. Now, this is waiting for listening on that queue, and it picks it up, and it then sends a message back to another queue, which this one is listening to. Now, this is nice because now we've changed a couple of things. The first one is that all of these things are more independent, because if we look at the first problem with latency, there is no longer a latency, because with every single message that's put down there, we've committed our state. So we can actually go on forever, basically, with messages triggering the next service. So there's no more latency problem because there's no longer a single thread triggering everything. The second thing, which is nice, is that let's imagine I've sent this message here and this service is down. That's not a problem. The message will just wait there until the cheese getter service returns to life. That works pretty well. So this is a little more fault tolerant. This was a really nice change. And actually, this is probably how most modern architectures start today. If you were building a distributed system right now, you would have a lot more than this, but the basic idea is you have some kind of message broker. Kafka is just an example. You could use anything you like, really. And then you would have this as a center point for messages. And then you get your response. But there are some problems. Parallel tasks are hard. Now, when I say that, I don't mean that doing two things in parallel is hard. That's really easy. The hard part is waiting for two parallel services to complete before moving on. That's a hard thing to figure out, because who is in charge of making sure that these things are synchronized and that we can continue and do another message or something? It's more complicated, especially when you get more and more parallel things happening and you need to wait somewhere. Maintenance and update is a little bit hard, mainly because it's a little easier than it was, but maintenance of this is complicated. Here's an example. See this service here? This is throwing a gimme cheese message right here. And this one is waiting for a message called gimme cheese. Okay. Now let's imagine a scenario where, okay, we need to change some stuff. We need to add a service in the middle of the get me cheese. And now if we do that, we need to change this service and this service. This one now needs to wait for a different message, and this one needs to send a different message. So you can end up having to change multiple services because the order of the services you're running has changed, which can be a bit annoying, but still better than the previous one. It's still a bit of a black box. The problem of which services call which is actually still an issue because we don't really know what's going on. Because we're sending a bunch of messages and they're being picked up, and it can be really hard to see an end-to-end what is happening. So that was happening in software architecture, all the way from dinosaurs up until event-oriented architecture. I hope you all took notes. Now, meanwhile, there was other stuff happening, obviously. And one of those was there were people designing systems with BPMN. For those who may not know, Thomas showed a BPMN model in his talk. It was quite cool and complicated, but anyone who hadn't seen it before could probably understand that that is a design for a process, a series of events that are going to happen or tasks that are going to be completed. And this started as designers were building ways of seeing how processes interact, how decisions are made, and what happens when certain decisions are made. And this wasn't happening in the technical sphere at first. At first, it was just diagrammatic. Eventually, BPMN 2.0 came along, and that meant that we could have process engines that could read those models and then create a process engine out of that. So how does that change? Well, the first iteration of process engines were a little bit like monoliths. They actually were embedded inside existing software. So the process engine would be here. And if you wanted to orchestrate some stuff, you would stick your services around here. And the process engine was in charge of deciding what happens in what order. So if my little bird wanted to do something, it would request the process engine to start the process. And the process engine was in charge of running this. Then depending on the result of this, it would decide whether to do this or this. That's really different from what previously existed, mainly because the decision-making is no longer here with this service. In the previous one, this service had to decide what happens next. Either it's calling another service directly or it's producing a specific message. But in this case, it's just saying, I'm done, and here's the data, and the process engine decides itself then what to do after that. So then we had something like this. This is a nice little BPMN model in Camunda 7. Now, I mentioned already that transactions were the key towards those long-running processes that use threads and stuff like that. Well, the original engine in Camunda 7 and the first engines that showed up were transactional, which meant they ran as much as they could in one transaction. So you see that they would start the process, run across here, and then stop. And then eventually they would pick back up and run the next bit. Now, why were you doing that? Because we were limited to the number of database commits we had. That was a limiting factor. And so every single time we committed our state, we would be using resources. To make the engine go as fast as possible, you limit the number of resources. So what would happen would be we'd start this, we'd run all this in a row, and then we would commit. This is quite easy. within a single application. But then we talked earlier about what happened when monoliths exploded. We got distributed architectures. Now we have external services, and we can't really have the same type of. I'm going to just skip that slide. Great. So we can't have the same problem with distributed systems. First of all, long-running services are a problem. You can tell because I used in a case a problem. Now, long-running services, by which I mean anything that lasts longer than about 5 minutes, because long-running services then are limited to how the engine can run service, which is limited by the threads, which is the same problem as distributed systems had. I mentioned already, wait states equal resources. Every time you wait, you had to commit resources, and every time you made a call to the engine, that was resources as well. And the database was the bottleneck. And just as Camunda 7, sorry, as Camunda, as a company that we were, at the time we were thinking, how do we make our engine go fast? Database is the problem. It's the bottleneck. That's where all the things are. That's our limiting factor. We have a certain number of commits we can do in a database per second. What can we do to improve that? And we did a lot to improve that. And then one day, our CTO, Daniel, he decided, what if I built a new engine from the very beginning and I didn't use a database? Let's imagine that I just used events instead. So instead of having to commit a database, we're just producing events for everything that happens onto disk and just running through the process that way. And we kind of experimented with that idea of removing the database completely, because that would remove any limiting factor to the speed of the engine. And that's kind of what started to happen when we created in Camunda 7 the external task worker. Now, if you're using Camunda 7, you probably already use this. I hope you do. The external task worker was a really big innovation in Camunda 7. It meant we could then start orchestrating services that were not local, not in the monolith, but rather external and in different services. So you have an external worker somewhere, you have a corresponding service task in the model, and over network, they're going to connect and do some work. And the worker is going to work on its own thread pool, on its own resources, and the engine's going to wait for it to be done. So now we can do all sorts of long-running stuff. And the way that worked was we were able to say, send a request to the engine. The engine then would decide this thing does this thing and returns back, says, I'm done or I'm not. And the engine would decide what happens next. In this case, the engine might decide, hey, let's call this service or let's call this service. The important thing is there's no longer, this looks very familiar, I guess, to the Kafka one. The big difference, the big difference is where the decision-making takes place. In the first version, this needs to decide to run this by sending a message that will be consumed by this one. Not in this case. In this case, this will always send a message saying, I'm done and here's my data. Then the engine has a model that someone has already built that decides on under what circumstances certain things run. And it might decide to run this one, or it might decide to run the other one and then respond. But either way, these are now independent of each other completely. So this did make parallel tasks a lot easier. And if you look at the Kafka example, Kafka never makes decisions. That's the big difference. A process engine has a model that has defined paths. And with something like a message broker like Kafka, there's no defined paths. There's no preordained route taken. It's just a series of topics and logs, and they're just hanging out, having fun. Updating became way easier because we now have a single place that we can update without affecting anything else. And now we have, for the first time, an actual visualization and clarity. And once we saw that working in Camunda 7, we decided then to implement an event-based process. We take the event-based speed of what Kafka and other event-based components were doing, and we decided, let's try and make a process engine that does that. And that's kind of where we're at now, where this is a diagram we showed earlier, where we have now an event-based engine which doesn't use a database, and instead is able to self-cluster internally and is able to run across network externally. Now, This is a very, very big innovation. It means we have infinite scalability. There's nothing slowing us down anymore. We can have multiple gateways, so we can have multiple ways of accepting input from any number of services. We also have an infinite way of growing the number of brokers in a cluster, and no database to slow us down. I'll give you some numbers. Camunda 7 with the database, with the best we could get was about 1,000 instances per second, which is still a lot. With Camunda 8, we kind of stopped counting after about 1 million instances a second. So it's a big, big difference. We could have more. It just costs more money to run more servers. Now, at this point, I need to remind everyone that at the very start of this talk, Maria said that I should talk about connectors. And so who am I to say no to Maria? So now I'm going to show a quick demo of how Camunda 8 looks and works, and we're going to use some connectors to do that. So let's start off. This is called South Africa. This is our model. Bear with me. I'm just going to wing this. So let's see what we can do. So we're going to do a rugby predictor. Now, people may know that at the weekend, a very important game is happening, and that is we want to know what rugby score will be. That's not even a good English sentence, but that's what we're dealing with. And we're going to actually decide to predict this. So let's say predict game events. Because we don't want to score. We want all the events that happen. And then after that, we are going to see that prediction. Prediction. Great. And what I'll do here is I'll use, well, let's first of all start. This is a very simple process. I'm going to start, before I use connectors, I'm going to go into implementation mode, and I'm going to use a form to start off with. So I'm going to create a user form, and I want this to be dynamic. So let's go with this, and let's call this the rugby prediction wizard, because the word wizard hasn't been around since 1998. So I thought I might just throw it back in there. And let's go here and let's say team 1, because we want this to be dynamic. So let's say, which 2 teams do we want to predict? Team 1, and this is team 2. Okay, great, we're looking good. So they're the 2 teams that we'll predict. So let's go back to our process, and let's attach that form to this. There we go. So now we have a form on our start event, which is going to look like this. Next up, I'm going to use a special connector. This is our OpenAI connector. So this means it connects to ChatGPT, and it is going to give us some predictions. So let's go and build that. So the first thing is, you can see that here I've chosen ChatGPT, so you can see that all this has changed a little bit. So I just need to fill in some bits and pieces here. Now this means that the engine itself has a way to connect to OpenAI, and I need to fill in some stuff. So I'm going to let's see, the prompt here, I already have an idea. Okay, so let's do this. It says, okay, can you predict between, so let's get rid of this, team 1 plus and, oops, I've forgotten some pluses. So this is just making it more dynamic and cool. And team 2, you can see the autocomplete there, which is pretty class. So it already knows the variable exists. So we have, can you predict, let's get rid of England there. Okay, and that's probably good enough, I guess. Yeah. Okay, cool. And then we're going to get a response, and that response is going to be a prediction. prediction. I'm going to add one more thing to this, actually. I'm just going to add use markdown and emojis, because I love emojis. Okay, that's cool. So this is our response. So then I'm going to go in here and create a new form. So this is going to be our C prediction. Let's go. This is going to be whatever ChatGPT tells us. So let's just add their prediction. And then whatever they say is going to be this. Just going to put the prediction in there. So whatever they predict will, I guess, be good. So now let's head back to South Africa. No, not that one. The model. There we go. And let's attach the form now. There we go. Attach the prediction. Great. So that should be work. I'm going to give this rugby, just call it rugby, sure, why not? And what's wrong with this one? It's still complaining about something or other. Let's try and just attach this. Embed. Hoorah, great stuff. This is called rugby, great stuff. Let's now deploy this. So this is now an executable model. It's important to know that this worker is external. So it's just, imagine like when I look at all the connectors here, imagine that these are just loads of little services, little microservices that are just hanging out somewhere in the cloud that I'm able to connect to from here. So this is the kind of stuff I can orchestrate. So let's deploy that to column the cluster. Great, and let's deploy. It should be okay. Yep, deployed. Let's run this. So that's team 1 is South Africa, the Springboks against England. So let's see. Let's hope for a good result, folks. So as I click this, it's going to start an instance of the process. I'm going to fly over to operate, which was shown very briefly by Thomas. And operate is going to show us what's going to happen. So it's now in the prediction section. So let's hope that works, because I haven't tested this, so I really don't know. It could throw an error. We have no idea. So it's going to try and contact ChatGPT, say, here's South Africa, here's England. Oh, it actually worked. Shocking. Okay, so let's open the task list. And if I also did this correctly, it should be able to show me the prediction, and we'll find out. I'm very much looking forward to this. Okay, here we go, folks. So it's South Africa 24, England 20. Great stuff. So first half begins South Africa, strong offensive, putting early pressure on England defense. Very happy to hear that. Oh no, England rallies back. It's a turnover. Oh, no, this is getting too exciting for me. Okay, and at the end, note, this is a hypothetical scenario, not an actual game. So we could beat England by more than that. So yeah, that's my incredibly quick demo of connectors that Maria asked me for, but I don't want to do this all on my own.
Thank you for indulging.
No problem. This is
Great.
just for you. I'm also going to add some additional stuff so that everyone here can play. So I'm going to add parallel gateway. I'm going to add one more connector, and this is going to be a SendGrid connector. Great stuff. And I actually hope I remember how to set this up, because sometimes I don't. And let's see. Let me just take a look at my various predefined stuff. Actually, Marie, you know how to do a SendGrid connector, right?
Yes, I do.
Cool. So talk me through it. So I want to send an email. And I guess
put your SendGrid key, which is double, yeah.
So secrets.
Yeah.
Oopsie.
Oof.
Dot SendGrid.
Yeah.
I guess. Cool. Name will be.
Name of the sender will be community, right?
Let's go Rugby Wizard.
Rugby.
Rugby Wizard.
Edition, yeah.
Community@camunda.com. Receiver will just be name.
Email.
Will be email. And
incredible prediction.
Let's see. Sorry about that. I just need to type stuff. Subject will be. Let's do another. Wizard. And this is the body is going to be whatever is in here.
Yeah.
So the prediction.
Prediction. Oh, I remembered. I was paying attention.
There we go. Okay, so that looks like it probably might work. But now we need to change the form a little bit. So I'm going to go in and I'm going to go into my form. I'm going to add a few more things. Let's add a text box here for, let's just maneuver this around a bit. So this is email. This is name. Great. And then we need an email. Let's just type that email. Great. And let's also make sure that people don't type in weird stuff in there. So let's go with validation of email. So now you can only type in emails. Great. Let's reattach this to our model. Remove the old one. Attach the new one. Cool. Now I'll do one more thing, which is I'll make this public. I have no idea if this will work, but we're going to find out. And I'm not going to bother testing it. Instead, I'm going to create a public link. So I'm going to make the audience test this. We're going to put this link somewhere once it's deployed. There we go. There's the link. Now, can I access the chat from here? Let's just stop sharing for a moment. Yeah, Kennedy, glad you got the score. Okay. Let's just put there's a link in here. Go ahead, click the link and see if it works. Yeah, I've no idea. I'll share my screen so we can watch to see if any processes come through. So let's see if that goes. Share screen 2. Great stuff. Can you see operate? Oh, we have one. Did someone already start an instance? They did. Let's see if this works. France and Argentina. Okay.
I mean, I don't even know if they're going to play against each other again or not.
Very unlikely, since France have now been knocked out by the very people who are in this call.
Cello has a question. So what happens if you just add the form without removing the old one? I believe that you cannot just add it. You need to actively remove it and then add it again. But it's a very good feature request, overwriting a form. Like
we have the look. Yeah, I do agree. We have that on the list.
Yeah.
Okay, that's that prediction. We have. Wait, are these all England? Did I hard code it incorrect? Oh, wait, there's France, Argentina.
No, you didn't hard code it.
Who did that one? These are just a bunch of predictions that are coming in. So yeah, I'm just. How many instances do we have? Whoa, loads of people. Look at all this. This is crazy. I shouldn't have opened this link up to everybody, but there we go. Thomas is going with Germany and Japan, 2 teams, I would say, not known for their rugby. But okay. I will stop sharing now. Actually, no, I won't stop sharing. Do you know what I'll do? I will do this other cool thing that I'll just quickly check. I want to see if this works. I'm going to find out the most common teams people have pitted against each other, because we also have this lovely tool here called Optimize. And now I'm completely off topic, but you should just bear with me. So I want to create a new process or a new, I have no idea how to create a new one now. I'm in dashboards, collections, new report. I'm going to choose my rugby one. There it is. I'm going to create a report. Let's just see how many instances have already been created of my rugby game. Let's do this. 10 already. Well done, everybody. And now I'm going to group them by team 1. And we can see South Africa very much in the lead here with 4. We have Argentina, France, New Zealand, South Africa, Argentina, again, spelled differently, maybe. Okay, so there we go. Yeah, I guess I'll leave that there. Let me know if the email thing works. I don't know. I haven't tested it, obviously. So maybe it will, maybe it won't. Okay. So cool. Hope you all enjoyed that and you stuck around. I did have other slides, but decided to ditch them instead. It does work. Thank you very much. Yeah, amazing. Great stuff. Yeah, hope you enjoyed it. I hope it helped understand a little bit about Camunda, and more importantly, a little bit about South African rugby, which is, why I really came here. Any questions at all? I am very happy to answer. Germany would definitely lose against Japan, Thomas. I mean, Japan beat South Africa 4 years ago, so that was a very big day for them. And Ireland also lost to Japan. So Japan, they're not a great team nowadays, but they were very good. So a question about the public API. Yeah, we do actually. So the API is exposed. It protects against bot attacks because we do have the server itself has a protection from it'll stop malicious attacks already. So that thing is going straight to our server that has like Cloudflare or something on it. So it'll eventually stop it. Also, I'm going to take down that link after this presentation just to make sure that nobody does that. Valentine has suggested there's no way that New Zealand beats South Africa, and so I'm Irish, and after the suffering that I spent last weekend, I totally agree with you. There are a bunch of cheats that only win when they're lucky. So yeah, there's a lot of new stuff with Camunda forums coming up. I definitely suggest folks take a look. We have a lot of stuff come along. We have a lot more bigger plans for it, but right now it's quite a nice little way to build simple processes. Yeah, thanks for the question, Kennedy. Yeah, we do have integration with RPA. We have a bunch of connectors for RPA bots. All the usual crowd, BlueWorks Live, not BlueWorks, it's called Blue Prism, UiPath. Yeah, there are all connectors available for those. One more thing I want to show, which is actually brand new, which actually Maria mentioned, which is pretty class. Let me show you. It is literally the newest thing. So let me show you some of the connectors. Now, let's imagine. So there's a bunch of connectors there. There's UiPath, right? Now, my favorite one is Robot Framework, but there is no Robot Framework. So what do? We go to the marketplace. And so these are all of the connectors that you can add to your from the marketplace to your model. So the ones I have installed aren't all the connectors. They're just the ones I have installed. So you can see there's a lot more. And you can add your own to these. There's Blue Prism. You can add your own to these as well. You can submit community ones and then add them. In fact, this one here, I helped build this Space Traders one, which is a fun game, which I think is worth playing. So yeah, that's an additional thing as well. Let's stop sharing. Great stuff. So great question on the forms. The forms are not that customizable yet. And I'll tell you why. Because we don't feel they're so feature complete that we want to be able to do the final things like being able to change the look and feel. That'll come later. We have a lot more things to add to forms first, like dynamic embedded elements that people can add themselves, that sort of thing, once we add that. Yeah, I agree with Thomas there. There's some other great options. I happen to use Camunda forms, but you actually don't have to. They're just the easiest way I find to use them. You can use all sorts of forms if you like. Camunda orchestrates external services. You can have external front end somewhere that you can orchestrate. Kennedy's asked about advising on security. I agree. Use security. Do you have any more details on that, Kennedy? Any more specific security stuff? When it comes to the marketplace, all of the connectors are run through a group internally that checks them, so they're all fine. In the future, we'll be marking them all with certain labels, so you know which ones are built by us, which ones are partners, and which ones are community. In fact, that might already be the case. So batch processes. Well, that's really easy because you can you uninstall default connectors? I don't think you can uninstall the default ones. Not on the SaaS version. You can definitely do it on the self-managed one for sure. I know that you don't like seeing brand names on your models there, Thomas. I think that's your issue, right? Yeah. Just get used to it, man. We live in a we live in a capitalist society. You gotta get used to those brand names. Okay, so I'll batch processing. We don't really need batch processing with Camunda 8 because it's event based, so you can just run stuff in parallel. Yeah, you can stream events from Camunda. Absolutely. We have an event. Everything that happens in Camunda, we have a JRPC API that you can use. But we also have the ability to plug into the event stream of the engine, and you can do stuff that happens with the engine. Or you can like read the things that happen. So I guess I can probably stop talking now and let someone else talk, because I've spoken for about 45 minutes, which I think is my allotted time. I'm 1 minute over, so I'm sorry for that. I guess I'll throw it back to Maria or Kennedy, whoever it is, would like to take it off my hands. Thank you very much, everyone for listening.
Yeah, thank you so much. Thank you so much, Niall. I don't know if there's any other questions from the team. Okay, Valentine, you guys. I think on the team we actually got a lot of guys that have used BPM for quite a long time, and they've literally used some different products. That's why you can see some of the questions coming down. So I think if there's no other questions, yeah, sure, right. If there's no other questions, maybe we can take another maybe 5-minute break. Then I think we also gonna show the South African team the work that they've been using Camunda. So they will be showing the work they've done using Camunda as well. So I think we can just convene in 5 minutes time. Then we'll start just showing also some of the work that's been happening on from the continent as well. Yeah. Okay. So let's just take a small break. I see Valentine has got a question there. Say how complex would it be for a Java developer to be accustomed to Camunda?
Sure. Can you mute yourself? Great. Okay, we're good. Very, very easy. Let me incredibly quickly show you a Java-based worker that I have here locally. I got to open it first, of course. Now, what would I have called it? Probably connector demo. There we go. Okay, so let me actually just very quickly show the Java. So let's imagine you've built a Java application and you want to orchestrate it. That's pretty common. I'll very, very quickly show during the break what that might look like, because that's fun. Okay, so here is my connector. So here's how it works. Here's a Spring Boot application. I have here somewhere a POM, no, not here, sorry. In here, in my application file, the location and how to connect to the engine that has the BPM model. And then I also have a little bit of Java here that does the connection itself. So you can see here, the key thing is this, which is called make Niall do work, which is something that it requires a Java application to accomplish. And here is connecting to the engine by this key. The way that would work, so all this is just regular Java. We have an SDK for connecting to the engine, and then whatever you write here can be orchestrated by simply opening up one of the models. It's just kind of this, and you would just change this into a service task. Second. And you would just correlate that by my computer's been a bit funky, by saying this does make Niall do work. And then you start up the little Java application, and then it points to the engine, and then everything else is orchestrated by the BPMN engine. It's very, very easy. I think I have a video coming out about how to do that exactly. There's none in Golang. There's some in Python, JavaScript, Java, C#, but here's the key thing. All the API is done in gRPC, right? Which means you can generate a Golang client from it. So it's not difficult. You could just generate a client from the API. So I would do that. And if you do, put it online and share it with the world. There was a Go one some time ago, but I don't think it's been updated for the newest version, which is why I mentioned I wouldn't go to it. They're the ones that are maintained. Thanks, Thomas, for your lovely memory. I shall go now. I think I've been speaking for too long. Enjoy your time, folks. I'll be back.
Okay, so catch up in 5 minutes time. Okay. Okay, I guess we can resume. Okay, I hope if everybody's listening, can I? Okay, I think I'll just start from my side. Okay, just okay.
We are seeing
the
wrong view.
Can you say the PowerPoint? All right.
We
You
were
can-
seeing the slide master controller thing.
Oh, is it? Okay. No, I think now you can see it's like the PowerPoint, right?
Yes, we can see the PowerPoint.
Yeah.
But no, it's
Alright.
slide mode.
Yeah, that's fine. So I'll just give a brief of what we're going to demo today. So we've been working as a team. We are part of the KaribuTech team. We have been working with a medical a team of doctors from Zimbabwe, where we came up with a medical administration system. So I mean they played quite a key role in defining this process with us. So you find that some of the I'm just going to go through a quick brief of this process and why we also decided to use Camunda as our central component. Yeah, one of the key things that they wanted to do was to track their surgery processes because they've got quite a lot of rural hospitals that they're running, which are networked, which they actually wanted to manage quite a lot of things. One of the key things was to manage the workflows and the patient management. Then the other one was also to look at maybe things like vital management measurement, then patient diagnosis, surgery, and medical history. So those are some of the components. I'll just touch base on them quickly. So from a technology perspective, this is more or less the landscape that we went with. You will find that there's quite a lot of let me see if I can go to the full screen. What we went with was to actually use, from a front-end perspective, the why, like I said, we're dealing with areas where we have rural areas, where we've got the African space, where there's quite a lot of network challenges. So one of the key things was to actually try to give them options in terms of data because of those challenges that I have. So the mobile penetration in the African space is quite very good. So obviously having a mobile app was one of the options. But the biggest winner was actually them actually interfacing to this medical system using WhatsApp. Then also and USSD. Then also we've got a web interface, and also they're able to do bookings using email. Just by sending an email, then it goes through. So I think I saw Sonia was talking about using Kafka. For us, we went with ActiveMQ. So what happens is we can trigger appointments, we can trigger bookings with the medical center, where we just post messages to ActiveMQ. Then what we have, we've got some kind of listening, then that triggers our Camunda process as well. So the reason why we went that, then we didn't need to worry about what's in the background. So all these channels could actually just follow the same format and just post the message on the queue, and we could actually run our process in the back to manage our medical processes. So that's more or less the reason why we went that option. So most of our backend APIs are actually running Spring Boot. We also using Spring Batch for some of our batch processing. We have got Python, some of our Python implementations, which are also discussed in terms of the trigger, which is the bottom one that we actually want to showcase today, is where we do an audio to text conversion, where there is a conversation of a doctor and a patient. Then it does a conversion using the Open API, Whisper API specifically, then actually then triggers a Camunda process, where it does the automatic conversion from audio to text and retrieves the vital signs. So we also quite use extensively Lambda functions in the AWS space, and also some of our APIs are Node.js. So, so there's just different scenarios where we use some of these technologies. Then from an engine perspective, we're actually using Druze. So we actually interface Druze to actually run some of our rules. We do also use daemon within Camunda, but most of our rules are actually running in the Druze space. From a document perspective, we're actually using Amazon S3, but the reason why we kind of shifted a bit more into Menu was because it's very compatible with Amazon S3, but also it actually is something that we can run on-prem or on the cloud. So we actually went with using Menu in that specific case. And then we also use Apache Airflow for scheduling of most of our batch processes that we trigger in the evenings. Then that triggers our Camunda engine. This mostly our data interfaces that we're using. Mongo is our main database that we use for this whole health application. Then we actually also interface to something called OpenMRS, which is a medical specific data technology, which is based on health level standards called HR7. Then we also have quite a couple of adapters which we've written in Springboard, which are interfacing to Sage Accounting and QuickBooks that allows us to manage some of the accounting of the hospital. Then obviously from a reporting perspective, Optimize is our top one. Then we do have quite a lot of Power BI reports that we also run, which we embed on the front end. For our web, we're actually using React. Then also we actually have some reporting in Amazon QuickSight. and for the machine learning, we obviously running within TensorFlow and Open API. So as supporting technologies, obviously we actually running on Azure, where we actually using Kubernetes, Azure Kubernetes. Then for monitoring, we actually got Trencher, and we actually have Prometheus and Grafana. The DevOps, we actually obviously using mostly open source stuff with Jira and Jitsi as our chat technology. We really pure open source advocates. Then you find that our team of developers was quite a big mix, with quite a bigger team from Zimbabwe, a team from South Africa, a couple of guys from Congo, and about 2 guys from India that also worked with us on this. Okay, so then I'll go into the solution itself. I think on a high level, it just touches a specific concepts in the medical space, where we've got patient administration, where we look at registration, we look at bed management, we look at scheduling and booking. Then we've got the clinical space, where we look at the pharmacy, we look at the nursing, the outpatient and inpatient department. Then we also got some ancillary services, where we look at your dietary management and your lab testing and all that. Then from an interface perspective, we actually got a patient portal, a mobile and a web, where also patients can log in and actually view, but they literally just accept the appointments, which are all running on Camunda as well. Then obviously from a setup perspective, I've spoken about us running obviously in Kubernetes and all that, so I won't go much into it. Then from just from a high level, there is the approach that we did in the medical space was to actually look at 2-3 key components, where we treated a patient as our key component, and we also treated what we call a visit. So everything in the hospital is literally a visit. I think you'll see when we demo our Camunda process, we literally treat everything as an encounter, which can be an admission, which can be a consultation, which can be an examination, or a visual consultation, or a surgery in that case. All are actually treated as an encounter in that sense. I just listed some of the technologies that we're interfacing, which I've already spoken about. I think here it was just summarizing some of the features that we have in the medical system. But I think the focus today is just to look at the process itself. But I'm just obviously just highlighting some of the features that we have, from the basic feature where we've got e-prescriptions and admissions, which are all driven in Camunda. Then we've got some added features on the advanced side, where we actually got this advanced doctor-to-patient transcription, which we actually would just like to show today. From a what can I say? From a feature perspective, the key players of the whole system involve a couple of people. You've got the front office, which is the reception. Then you can see that they can do quite a couple. They can register patients. They can update the patient records. They can make appointments. They can cancel appointments and so forth. But these are all Camunda processes that they're actually running in the background. Then you've got the doctor. You've got labor assistants. you've got the pharmacy department that get requests for medication. Then you've got the IT team that also manage the system, and you've got the payments team, which is also just looking at the billing. Then yeah, so I think that's more or less. This just summarizes the role players, like I just discussed now: the doctors, the patients, the hospital staff, the administrators, and the hospital owners. And here you will see that these are some of the features just on high level that you get and who gets access. But our key players obviously are nurses and doctors and patients. In all fairness, yeah. So this is just summarizing some of those features in terms of patients. This is what they can do, and you can see. I mean, it was literally looking around appointment and scheduling. It also looks around. Yeah, so I think this is just the full ecosystem that you're gonna get. We also got some kind of a visual chat that you can also do. Obviously, this doesn't use Camunda as such. Then I think the key one is obviously that we really want to discuss is this easy transcription, which allows you a doctor and a patient to converse, to discuss something. Then after discussing, then it actually autofills in the data in Camunda. Yeah. So I think that's more or less in terms of the high level. Let's see if I can exit the full screen. Yeah. Just give me a few seconds. Right. What I'll do is I'll just give you 2 minutes brief of the interface. Then we go into the Camunda model, which Ngavile is gonna give us a brief of that. And Ngavile, you there, right? So practically, so this is our like I said, we've got quite a couple of interfaces. Then the main hospital interface is what I'm showing at the moment. I think if you guys can see it. This actually literally is what the hospital uses. We also have an interface for the patients from a mobile perspective, and from a what call it, and from a WhatsApp, like we said, and you can also trigger from USSD as well. So from here, obviously, you've got all the role players. This is where you've got all your patients that you can visualize the patients, and they can be able to do quite a lot of functions in terms of making bookings. They can also do appointments. Let me see if I can. So you can see that they can actually see their appointments here, but these appointments are actually driven by Camunda till the whole process actually finishes. Yeah, so more or less. So this is literally just keeping track of the patient. You can see we also keep track of the vital signs, where we measure your heart rate and actually keep them and actually just track them as at every point as the patient is going to the hospital. Then we also track the surgeries. We also track the lab test, the payments. Also, we actually track the payments as well in terms of maybe your surgery and so forth and so forth. So that's literally just on high level. I don't want to go much into detail, but literally that's more or less what the system is. Then obviously, like I said, the doctors are also driving it. They should be able to actually make a booking on behalf of the patient if they want to, or they can go and confirm bookings themselves and so forth and so forth. But there's, like I said, I mean, it's all those features I was talking about, where you've got your inpatient department, where they can also run and actually manage patients from there. They can do bed management and so forth. And but what you see that all these things are actually driven from a Camunda perspective. What I would do is I would just hand over to Nodili to actually showcase the Camunda side of things, which is driving most of these. What you see, we actually used Camunda 7 when we started, and we did actually drive most of our processes in Camunda 7. So I'll actually have and we will actually drive the just you want to just share your screen with me, then we can go through it from your side.
I share my screen for Chengeta now. Are you guys able to see my screen?
Yes, thank you.
Oh, okay. So this is the EasyMeds appointment model. So for the first, okay, sorry about that. So we have two types of data structures, which is we have unstructured and structured data. So for this demo purpose, we're going to be focusing more on the unstructured data, but I'm just going to give you guys a brief walkthrough on this process that I'm currently showing you at the moment. So here we have a collectivity, of which when I open it and I go into the process that's in here, we have WhatsApp, we have audio to text, we have WhatsApp, and we have email. So we used the REST outbound connectors from Camunda 8 in this integration of this process, of which my colleagues will give you a further demonstration of this process in what we have done with EasyMeds. And then we also have, or if here by this decision point you had chosen unstructured data, you are going to choose this option. But if you have chosen structured data, it's going to go into the database. We already have an API here which will search if there's a patient, the patient exists. If the patient exists, it then goes into the system to check. And then if the patient exists, it books an appointment, it goes to the appointment. But if the patient is not in the system, it then registers the appointment. So I'm just going to also show you the process that we have come up with for this. So as you guys can see here, we have registered to Mongo. So it will register to Mongo, updates open MRS, and then we also have a Salesforce connector, which is going to update the external CRM. And then, after that, you can then have a booking appointment. If I open booking appointment, this is what we have in this collectivity. We have a couple of steps and a couple of processes, of steps, of tasks that have to be completed. So check appointment details, check for available slots, whichever slot is available that you want to choose in that very moment, then you can choose that. You book an appointment, and then you choose the appointment type. So essentially here you can book a new appointment. You can reschedule an appointment if maybe the time you had chosen is no longer the time that you want to come through for your appointment. You then cancel. You can also have the opportunity to cancel your appointment. Here we have confirm appointment, which then sets a timer that will send a reminder to the doctor that, hey, you have an appointment at a certain time with a certain somebody on a certain day. We then update the MongoDB with the appointment details and notify the patient. So essentially, this is what this process does for EasyMeds booking. We have prepayment, which is you can pay before the consultation, which is the one. You make the payment, you wait for the consultation. We have timers, so payment not done, there's a timer there to say please confirm your payment, and then we have the timer that reminds the patient of, hey, you have an appointment on a certain day, and all that. So yeah,
on the notify, I think if you can see that at the bottom there, we're actually using ad hoc events. So the notify allows us at every moment, if we need to do a notification, then we can actually, based on the customer or patient preference, if they want a notification on the SMS on WhatsApp, then we actually send both. Or if they just want an email, so it just depends on what they configured on the profile. Then it just uses the connectors to either send the SMS and email at the same time, or you also get a WhatsApp. So, but the reason why we actually put it so that, at least because we reuse it in a lot of cases. So the other ad hocs there you're going to see is one for canceling, and the other one is also for receiving a payment. And we also got a couple where you actually also able to just maximize a bit. You can also do a reschedule and a cancel. The reason is you can do this now from your mobile app at any moment in time. It will come in as a message. Then once that message, so you saw our integration from all those apps. You're going through ActiveMQ, we update ActiveMQ, then we've got a listener from ActiveMQ. Then actually it goes into the specific process as an event. Then actually if it's a cancellation, then it actually do that. If we're receiving a payment, then we actually do the same for that same application as well. You can continue with it. Yeah.
Yes, and then from the we have the patient admission. I'm also going to take you guys through that because here,
I think you want to go into the consultation first. So yeah. So the first one is once you've booked your appointment and it's up, then you should be able to go through a consultation, and the consultation comes in with like I was saying, I mean, a consultation or an encounter takes different forms. It can be an examination, it can be a consultation, it can be a visual consultation, it can be a lab test, it can be just a vital check. So all those different forms are all part of the consultation or encounter. So that's why you can see there's different combinations there, and you can do a check-in. Obviously, the check-in might, if you don't do a check-in, you might be charged. So that's why you say you'll see that on the next step they might be a penalty for that. So if it's a consultation with the doctor, then that's also fine, which can be a physical consultation or a visual consultation. Then you also got a lab test as well. Then yeah, so that's more or less the consultation module. The way we've done all these modules, if you just want a consultation alone, then the process ends at that step and doesn't continue, and that's it. So it literally covers every aspect of the hospital. Yeah. You can go to the admissions. Yeah. You can go ahead, no?
Oh, here
Oh,
we
here we
in
in
the
the
patient
patient
admission, we have
admission, we have
payments
payments
required.
required.
So as you
So
can
as you can
see, we have another collectivity to make prepayment. We also have medical insurance authorization, of which this is essentially medical aid in a way. But I'm gonna start here by showing you the prepayment one, the make prepayment, which we have two tasks, which is prepayment and then the process of the prepayment only in this task, and then we move to the medical insurance, which we have medical aid, we which is just the service task which goes into the database to check if there's an insurance medical aid in there. And then we have another decision point where it's like surgery required. So we have a referral. If a patient is referred, and if we have a referral, we have no, and then we have if surgery is required, we have a process here that also houses that. So in this process, we essentially have the type of surgery. So sometimes people get to a hospital and it's an emergency, therefore it just goes straight to emergency department. Sometimes it's a normal surgery where people book and they come in the time that they need to come through. And then we also have maternity visits, a part of this process. But I'm going to be showing you guys the emergency department. So in the emergency department, we have this process inside in that collectivity where we have assess patient emergency condition. We have is surgery required? If the surgery is required, the surgery is performed. If not, the patient is prescribed medication, and then we move to the billing, which is also a core part in all our processes at the moment. Doc, is there anything that you'd like to include?
Yeah, I think that's okay. So for a normal surgery, you have to go through a couple of things. The approval process. The approval process involves quite a lot of things, which is getting consent. So in some cases, maybe we need your partner's consent or your parents' consent. So those are some of the things that you're gonna get in the pre-approval, where you actually have to get consent. And in some cases, we also have to check the payment again before you actually get that surgery going. So that's more or less some of the onboarding processes, pre-approval process that have to happen before a surgery goes in. You can go next. Yeah. Okay. Then after that, you actually then go through the surgical process, which is obviously involves quite a lot of surgery activities that have happened. Then after that, obviously you would have to, the day for the surgery arrives, then you find that the nurses will receive the patient. So the patient can either come in two forms, as an outpatient or an inpatient. And if you come in as an outpatient, obviously there's an outpatient department. Then they'll do the surgery in there. You'll find it's those minor surgeries that you're gonna get, like maybe you've got an eye operation or something where you're actually walking and you can just walk in. Then the other one is obviously the one where you get admitted in a hospital, you guys just see on means we actually got bed management around it. So that whole admission process that involves you getting allocated a bed and so forth and so forth. Then you prepare for surgery, then perform the operation. Then perform the operation then involves some post-operation operation monitoring, where sometimes they send you back to the ward again for a couple of days to recover after the surgery. So that's what you're gonna get around that. Where they obviously just do vital checks and so forth and so forth. I think you saw they were discussing about vital signs and all that. Then after that, after the surgery process itself, then it should actually just go back to the top level again. So there's a couple of outcomes that can happen after the surgery. I think we'd say you can get a referral, then you go to another higher hospital if you get worse. But most of the cases we go through what they call a discharge process. And discharge process has got different combinations. It can be a normal discharge where you do a follow-up. After that, then we just do payment billing, or it can be a readmission, which can happen, or you can actually disappear, which does happen. In that case, then the admin needs to actually find out before they sort out the billing. Then the other one, which is unfortunate, is death, which actually can happen. So the death part is quite a key one. You see there we actually using the signal event to actually publish that somebody has died, because what happens is if there's other bills in the system, then and other processes that are running in Camunda as well, they should be able to be notified, and actually then actually those processes take the required action. So that's why we actually have that section at the bottom. Just go back. Yeah. Right. So after the discharge process, you find that there's other things that can happen. One is obviously if you were deceased, then there's a process for deceased, and the deceased process actually has got quite a lot of activities that can happen. You can go in the. So one of the things that can happen as a deceased patient is you can actually, they process the death. Obviously, they will have to do death certificates and all that, which is the specific department, the mortuary department. But some cases, then autopsy might be requested, which in case the doctor gets involved, or there's a police case, then obviously an autopsy also becomes mandatory. So that's why you're seeing that component. You can go back. Yeah. So I think that's the key one. Then obviously, I mean, after discharge, there's a billing process that happens, and the payments team has to follow up and actually make sure that you pay your bills. In some cases, you find that we actually one of the key things we did with these doctors was to agree that maybe we also need to allow people to have loans in cases where there's complicated surgeries. So you find that on Izmez, we implemented medical loans. In that case, then what happens is the management of the loan will happen after this process. But here we obviously set the data to actually prepare the management of the process of the loan recovery to take place after that. The other piece is the drug management. So the drug management, what you guys can see there, is actually on the customer, on the patient. The reason why we put it on the patient is we actually want to track the patient. So what happens is on the patient portal, the patient actually has got a feature where you can actually be able to capture whether you took a certain drug or skipped the drug and so forth and so forth. So in that case, that gives us a bit more analytics downstream in the machine learning to be able to see when there's a bit of maybe the recovery wasn't as expected and all that. We know it's dependent on the patient himself giving updates, but I mean it's a stat. Now, obviously, we've got a couple of ad hocs at the bottom where you can contact a patient at any time. You can actually receive lab results at any time. You can generate an invoice at any time. You can receive a payment at any time. The reason why we made it ad hoc as well is because those things can come anytime during the process, and we should be able to just continue the process, but getting the bills and generating invoice whenever they need to. So that's more or less. Just go back to the top level. Okay, so I think from a demo perspective, what was out of interest, I think you guys saw. Just go into the pre-processing again. We actually looked at, let's look at these capturing scenarios And the key one that we actually want just to showcase is the audio to text, or we call it transcription, where we do a transformation. So in that case, we actually use something called Whisper API. And I actually got Danai, who is a student at the University of Zimbabwe. She's the one that implemented this for us. I don't know, Danai, you online? What she would try to do is to explain to you this Whisper implementation from a machine learning perspective. Then we actually just do the trigger of that process up to that step. We won't go further. We'll just show that step. Are you there, Danai? Okay. If she's not online, she did share a video, because I think she's having some network in Harare. I don't know, it's actually busy in Harare. I'll try to see if I can play the video. Just give me a few seconds. Right. Can you just give me I'm going to try to share and play the nice video. Hang with me. Okay, I hope you guys can see my screen. I'll just, okay. All right. So let me just play her video here. Okay. I think that was the second one. Let me see if I can show the first one. Okay. Yeah, wait. Okay, I think you can just give me a few seconds just to download it. Okay. Okay. Yeah, so I think what Dana is experiencing is what also our patients experience. That's what we're trying to see if we can actually mitigate in terms of the technology that they use as well. So I'll just play her video quickly. Okay.
Okay, so I'm just going to give you a brief introduction on what the OpenAI Whisper model is. So we'll start with what is Whisper. So Whisper is a general purpose speech recognition model. It is trained on a large data set of diverse audio, and is also a multitasking model that can perform multilingual speech recognition, speech translation, and language identification. It's a model by OpenAI, ChatGPT, you know. So how does it work? So here's the image that just shows us how it works. So a transformer sequence to sequence model is trained on various speech processing tasks, including multilingual speech recognition, speech translation, spoken language identification, and voice activity detection. These tasks are jointly represented as a sequence of tokens to be predicted by the decoder, allowing a single model to replace many stages of traditional speech processing pipeline. The multitask training format uses a set of special tokens that serve as a task specifier for or classification targets. So here is the image showcasing what goes on. So now we have the available models and languages. So we have these models that are available. The .n are for English, and you can see the memory and relative speeds of the models, and you can also see which models perform better than the other. So Tiny and Base perform the best, but the difference becomes less significant as we go down the sizes of the models. So basically, that's what it is. That's basically what Whisper OpenAI is. Thank you.
No, it's fine. I think I'll just share the video. I think
okay, so I'm just going to give you a brief introduction
No, it's fine. So I think I'll hand over to Vincent and Mark to actually show the implementation of this Whisper API. I think we'll just share the presentation that I did. I think it wasn't showing properly. Yeah, so Mike, do you guys want to continue? And just showcase the implementation of this Whisper API. Yeah.
Okay, thank you very much, Kennedy.
Yeah.
Don't know. Okay, so actually implementing generative AI and Camunda is one of my favorite things, was one of my favorite things to do on this platform. So in very much low network areas, you get to record audios or conversations between doctors and patients. And then later on, when they get a stable network, we get this unstructured data and we go ahead and we structure it. So we turn it into something that's meaningful, and then we get to get all the data that was shared between the conversation, how the patient felt, their heart rate, their blood pressures, their patient details, their IDs, and all that stuff. We get to get it from that recorded audio. So as alluded before, we're using the Whisper API to actually pick up that audio, transcribe it, and actually come up with text or an object that we can use to implement and start our Camunda process, and then go ahead, book an appointment, create a quick consultation, and see how the patient is doing. So now I'm just gonna allow one of my colleagues, I think Vincent, to just go ahead and share his screen. So he's going to show you guys how he actually goes ahead and do the transcription of that audio file. And then I think I'll walk you through task list and then show you the first implementation of how actually you get to see the details from that particular transcription. So this is quite a powerful tool. So I think I'll just allow Vincent to share. Is Vincent on the call now?
Thank you, Mark. Okay. So I'm going to share the part that I'm doing, which is the Next.js project that implements the Whisper AI, that is an integration with the Whisper AI. Confirm you can see my screen now.
So Vincent, you want to play the audio first, isn't it? So that the guys can hear the conversation. I think it's a 1 minute doctor-patient conversation. So for this exercise, we were working with another hospital in the US that we actually worked on that implementation. Yeah.
Okay. So maybe let me just play the audio.
You want to increase the volume a bit, Vincent? So Vincent, you want to increase the volume a bit? Yeah. Vincent, do you want me to play it from the side quickly? Because you can't hear anything. Okay. Vincent, you there?
Yes.
Yeah, we can't hear your audio. So
I think there's an echo issue. Yeah. Okay. So from this audio, so we have this screen that I have here. So this one also gives you an option to record. So if you click on record, then it goes onto your record. You can pause, then stop it. After stopping, you will also preview the audio, then also download it, right? So from there, then you have this section here, which you can click and drag your audio that you want to be transcribed into a text. So this part here will show the text that is generated. So from here, for the demonstration, I'll use the audio that I just recently played. So when I click on this one, so for now, it's now uploading it to the Whisper AI endpoint that was implemented by Danai, so that it retains as a text from the conversation. Just a point note is that with the audio to text, it's always not 100% match, so it tries to pick up almost all the details from the audio. So you can see for the vital signs, if your temperature is a 96, your pulse is an 86 radial, weight is 97.8 kgs. Okay, so from there, what then happens is you now have to submit this conversation. What this then does is when you click on submit conversation, it will then forward all these texts in a formatted object, which then triggers the Camunda process that Mark has been explaining all along. So when I click on submit conversation, then it uploads successfully. Then from my side, I think all will be done. Then for the next step on what happens after, I'll give it to Mark as the one who can then explain the next step from this one. So yeah, Mark, I think you can go.
Okay, thank you very much, Vincent. Can you allow me to share? All right. Okay. Okay. So I do trust that you can see my screen now. So from the instance that Vincent has triggered, I think it's this one. That's 8:07 now, my local time. So from here, we managed to get a couple of details about the patient, right? So we get the patient's details like their names, the patient's IDs, the actual case number, and then this is the text that was actually transcribed, right? So in some cases, we might be able to pick up all the data that was created during the conversation. So we might be able to pick it up sometimes, and sometimes we might not be able to pick it up. So Camunda, normally the forms that we created pick up some data and leave some data out. So for transcriptions, so we just added the raw transcription so that whatever data was missing from the whole conversation that we had can also be picked up from here. But this is basically the object that gets created from the conversation that was being had between the patient and as well as the doctor. So in this case, we would have leveraged the use of generative AI and those to actually get this data that would have been recorded maybe a while back, and then would go ahead and book an appointment and then just do some consultations with the patient, and we go ahead and we happily continue with our process. So we could select what type of patient is it. If I assign the process to me, we could actually select what type of patient is it. Is it an emergency patient? Is it a walk-in patient? Based on the data that we would have received from up above. So I'll not take you through most of the stuff, and then maybe I'll sway just a little bit to one of the other use cases that we did leverage and maximize the use of Camunda, which is probably appointment booking. So basically for appointment booking, we may have some appointments that might need to be monitored. So we thought of what we could use to actually monitor these appointments, track them. Maybe it's illnesses that are going to happen for a long time. And then we thought, what if we leverage and we use Camunda to actually store these appointments, track these details for different patients and all that stuff. So I think I'll just allow one of my other colleagues, Wellington, to go ahead and show us how we actually go ahead and book an appointment from our EasyMeds front end, and then how we get to see all this of unfolding on our task list as well, and then we get to monitor the data as well. Yeah. So I think Wellington, you can take it from me. Yes.
So I will just try to quickly share my screen there. Okay, I trust you can see my screen, right? Okay. So,
yes, we can.
Okay, thank you. So from here, I'm just going to quickly create a new appointment for a patient within our system. So I'm just gonna do some data capturing there, so bear with me. So what I'm basically capturing here are the details we need to kind of create our appointment, right? So you can choose a specific appointment date and a specific appointment time, and optionally you can suggest another date that you might want to select there. So that's just an additional date, and I'll go ahead and capture further details below. And then I will go ahead and confirm my appointment. So from here, it triggers a Camunda process, and a new instance will be created. So I will hand over to Mark again. So over to you, Mark.
So also you get an email confirmation as part of that booking as well.
Okay, thank you very much, Wellington. So let me just go ahead and share again. And then, okay. Okay, so I do trust that you can see my screen again. I'm sorry for having multiple processes. Now we can't figure out which one is which, but I think from my local time, we can look at this process that has been created, this instance that has been created now, and then a task has been created as well just now. And then so we could now then just go ahead and view the appointment details that have been triggered by Wellington. So from here, we can see the patient details, the appointment details, the doctor's details, and then the locations. So after checking if all this data is actually correct and is actually meaningful, we could just go ahead and approve or decline the process. So if I just assign this to myself, we could just go ahead and approve or decline this appointment so that it can carry on, and then the patient can get a select date, like what Mavile was showing in that Camunda process. They can get a select date in which they can come for a particular checkup. If it's an emergency appointment, they can get a closer or a much more faster date in which they can come for that particular appointment. So that's basically what we have and how we have used Camunda to actually leverage some of the stuff that we're so excited to show you, the audio to text review and actually the booking of appointments. So we could actually monitor and go through these appointments from start from A to Z, no matter how long they are. So I don't know if Kennedy has something to add on that. So yeah, guess that's all from me.
Yeah, I think that was our demo, and obviously I think if there's any questions, yeah. So I think the key part, you guys can see that we actually centered around the workflow model in terms of our implementation of the whole hospital administration process, like what Mavile was demoing. I think Mike, maybe you just want to show the optimized component as well. I think, but Neil has shown us even more stuff. But we actually just also using optimize, as well, in terms of monitoring as well. So I think that's one of the key components. We've got a couple of ladies that are actually doing analytics with Mathoni and Pete, who are also part of the discussion. Literally, their job is just to do analytics and machine learning. So they actually use Camunda Optimize quite a lot over and above other analytics engine and that they're also using. Some of the key components that we're also trying to add is I think is mostly in terms of analyzing. The reason why we're collecting all this data is actually then to sit with the Dr. Wazara with our partner from the medical space, where we actually then want to look at that data, mostly in terms of the drug space, where we actually want to then analyze that drug and predict some of the diseases that are happening in the process. So that's some of the work that we already starting engaging with him. And also just to let everybody know, we're actually going live with this in the next couple of weeks. So we actually busy discussing with Dr. Wazara in terms of implementation and testing. So it's quite an exciting journey for us. Yeah. Okay, I don't know if there's any questions. Yeah, I think I also want to give a lot of gratitude to one student who is, I don't know if he's joined us yet. We also got a student from another university in Zimbabwe called Panashe. He's the one that started this project. He limped along for almost a year on his own before we actually beefed up the team with about 20 extra developers. So I think he was really the brains behind all this. It's just he's gone back to school at the moment to continue his assignments, but we actually quite give it a lot of thanks to him because he was really driving this implementation. Yeah. Okay. I don't know if there's any other questions in terms of maybe what Thomas presented, what Neil presented, what Maria presented. And I think we also want to give a lot of gratitude to Mr. Repeira. He's the one that has been supplying most of the students that we've been working with as well, from University of Zimbabwe, for instance, as well. So I think he can also see a lot of former students of his as part of this implementation. Most of our guys are actually below 25 that are presenting here, if not all of it except me and Justice as well. Yeah. Okay. Yeah. No, it's not hard configured. It's actually dynamic. So I think if look, maybe Dimakaso is also part of the team. She's been driving quite a lot of work for us. She's our cloud or AWS and Azure engineer. So the way they've configured in terms of the infrastructure as well, we can actually roll in a new hospital implementation in very quick time. Yeah, so I think also thanks a lot to Democracy as well. She's also our Scrum Master as well, so she actually wears two heads and has been driving quite a lot in terms of implementation as well. Yeah. Okay. Is there any other questions? Yeah, Maria, I think I think maybe I just wanted to show just a quick the Camunda saving. You also see that on Camunda saving we actually have yeah. So on Camunda saving we actually have a case where we also have microprocesses that we run. You will see the on EasyMaze we can actually originate different process levels where you can actually originate a drug process on its own. You can have a patient admin. Those are separate processes you can run separately if you want to, and you can see the history. So this is now on our React front end where we're actually showcasing that. as well. The one that we demoed today was the master process that incorporates all these microprocesses and runs through. But if you just want to go and trigger one specific one, it will actually just come and do it for you in that case as well. So you should be able to be able to just run through that specific scenario. Okay, so Mr. Perry, you're saying you've been interested in the NLP doctor-patient conversation. So that part is quite an interesting component for us because what we're trying to do, like I said, we're working with a hospital in the US, which actually came up with this proposal. We actually have a demo with them next week. So where we actually have included all that in terms of the Camunda implementation as well. So it's also quite an interesting component as well. I think what Neil showed us is maybe something that we might need to look at, that connector, because we went away of that connector. So maybe we're probably going to have a look at that as well. Yeah. Okay. I don't know if there's any other questions. Okay. All right. So somebody, I think I don't know if you have any ways from your side. But otherwise, I think on behalf of the team, we're quite excited. I think this was our first African mainland chapter. So there will be quite more chapters happening. Obviously, we have a discussion with Maria, and I think there was quite a lot of interest in terms of the tech side, because there's quite a lot of workflow and experienced people like Valentine on the chat as well. Yeah. Okay. All right. Thank you very much. I think we also recording. If I think there was quite a lot of interest in Neil's presentation and Thomas' presentation as well. So I think Maria, we can chat, because I think I can see most of the guys are asking if they can also get access to those presentations as well. Yeah. Okay. All right. Thank you so much. Thanks everyone. Have a good night. Thank you. Okay.
Thank you.
Finally. Yeah.
Oh, the market.
Hey, we've been having stress about this day. Yeah, we are done now. Good work, guys. We did the nice work. Congratulations, team. Congratulations. Congratulations, guys. Congratulations. Ngobile, Madam, you were flowing. Wellington, Vincent, I Siavong.
Thank you. They represented us
well. They did present us. That was nice. That was good. So see you guys month end, Fire Room, Mall of Africa. We're going out for lunch. So bye.
What is the budget?
Hey,
what's the budget?
This time we don't have budget. Everything is in the house.
Okay.